Number 40, we're told to factor the expression completely, and we've been given 25x squared minus 16y squared. Now remember, when you are factoring, you always have to ask yourself two questions. The first question is there a GCF? So if we look at this expression, is there something that we can pull out of both of these terms? And in this case, there's not. There is no GCF, so we move on to question number 2, which is how many terms are there? Because the number of terms will reveal to you what method of factoring you'll be using. If there are 2 terms, you should be looking for the difference of squares. If there are 3 terms, you're going to be looking to use the scissors method or the AC method or the trial and error method. Of course, in class we use the scissors method for my students, but your professor may have shown you a different way. If there are 4 terms, you're going to be looking to factor by grouping. All right, so we've already established there's no GCF here. Question number 2, how many terms? In this case, there are 2 terms. This is a binomial, so we should be looking for the difference of perfect squares. And indeed, I think that's what we have going on here. So we know that this is going to factor into 2 binomials. We can factor this first term, 25x squared, as 5x and 5x. Why? Well, what's the square root of 25? 5. What's the square root of x squared? Well, x, so we have the x. We know with the difference of squares, 1 is always plus, 1 is always minus. And now we take 16, ask ourselves, what's the square root of 16? We know it's 4, so we pop in 4. What's the square root of y squared? Well, we know it's y, so we pop in our y's. And so there we have it, number 25. When we factor this expression completely, we end up with 5x plus 4y and 5x minus 4y. And again, just like we mentioned in the previous videos a couple back when we were dealing with binomials and foiling, you could foil this back together to make sure that you wind up with the original expression that you started with. And indeed, if we were to do that, we would find that we do. So there's number 40.